Hi, welcome to Math for All, where everyone can learn more about math. I'm Denise, and I'm here to help you learn some basics on straight lines. It is actually quite shocking to realize how much we can analyze a silly line, but it's pretty powerful stuff, so we're going to get to it. Before we hop into this introduction, please go to my website, MathforAll.net, and print out notes with fill in the blanks so that you can follow along with this video and you'll be able to reference it later. This video will give you a great foundation of what the lines are that will help you as we dive deeper into more of their characteristics later. So far, you have seen where we have to solve for a variable like this. 11 equals negative 3x plus 5. We would go through our steps and get x equals a number. Today's equations look a little different. Y equals negative 3x plus 5. Wait a minute, we have two variables, x and y. So how are we supposed to solve this? When one of the variables change, the other one will too. There are infinite answers. Mind-blowing, kablooey! I'm going to list the steps of what to do to solve these right now. I say right now because as we learn more, we will use some other tricks. Step 1, make a table with x, the equation, y, and then point across the top. Step 2, choose your favorite x values, at least two of those. The best choices would be 0 and then 1. Or if your equation has a fraction like this, 2/3 x plus 10 equals y, choose 0 and then the denominator next to the x, in this one 3, so that the fractions will go away. Step 3, plug in your x values into your equation and evaluate it, then put what it equals under the y column. Step 4, translate your x and y into a point. Basically, just put the x, y in parentheses. Step 5, plot your points on a graph and connect them to make a line. Put arrows at the ends. That is a lot of steps. Let's do a few and you'll see that it's not so bad. We'll follow along to do y equals negative 3x plus 5. Make our table x, negative 3x plus 5, y, and point. We'll draw lines to keep it neat. Step 2, we choose our x values. I will choose 0, 1, and 2 since I don't have any fractions by the x. Step 3, put in our x values and then evaluate. Negative 3 times 0 plus 5 equals 0 plus 5 equals 5, so y equals 5 here. Now I'll repeat that with x equals 1. Negative 3 times 1 plus 5 equals negative 3 plus 5. This time y equals 2. Now I'll put in x equals 2. Evaluating, I have negative 3 times 2 plus 5 equals negative 6 plus 5, and that boils down to negative 1. This next step is easy. You just copy down your x's that you chose and then put the y's you figured out right next to them. 0, 5, 1, 2, and 2, negative 1. We have created points that fit into this equation. Now we use a cool coordinate graph and we plot them. Remember that the first number, the x, tells us how far to go left or right. And the second number, the y, tells us how far to go up or down. 0, 5 is here. Move over 1 and up 2 for this one, and over 2 down 1 for the last point. Then we draw a line through our points like this and draw arrows. There are some important characteristics of this graph we just made from y equals negative 3x plus 5. The answers that we found created a straight line. In fact, All answers that work for this equation are on this line. So the solution to this problem is a straight line. When we have equations with an x and a y not raised to any visible exponents, the answers will always be lines. Let's do another example that looks a little different, but we'll follow the same steps and see what happens, and then talk about some patterns that we can pull out of the equation. Y equals 1/4 x minus 2. We make our table of information, x equation, y point across the top, and lines to keep it neat. Now, we choose our favorite x values. I always choose 0, easy enough. Because this one has a fraction next to the x, I will not choose 1 for my x. I will choose the denominator of my equation's fraction, this 4 here. Put that 4 under the 0. That way, when I multiply, there will be no more fractions. Step 3, we must do math now. Put the 0 in for x. 1/4 times 0 minus 2 equals 0 minus 2 equals -2. So the y equals -2. Put that 4 in now for x. 1/4 times 4 minus 2. 1/4 times 4 over 1. I can slash and turn these into ones, and the answer is 1. Don't forget to take away the 2 now. 1 minus 2 is -1. That goes here. Translating those x's and y's into points, I get 0, -2 and 4, -1. I could have chosen another x to try. I would have chosen 8 for another multiple of 4, but we know that it would just fit on my line that I'll draw in the next step. Plot my points. 0, 2 is here, and 4, 1 is here. Connect the dots from my line and then draw arrows, and it is done. Before we leave this awesome line, I'm excited to show you some cool patterns with these guys that are going to help us graph them later with no table. First, let's look where the line crosses the y-axis. That's that one that goes up and down. It's at the point 0, -2. The -2 here shows us where it crosses the y-axis, called the y-intercept. Also, let's take a trip from one point to the other one. From our y-intercept, I have to go up 1 and over 4 to get to the next one. If I put my up 1 up on the top, my over 4 on the bottom, I get this 1/4 that is in my equation too. This is so helpful, but we can't use it just yet because there's a special form the equation needs to be in that we will learn very soon. Sometimes we may have to use this information to work backwards like this. Which of these points fit on the line? Y equals -2x plus 1. 1, 3, 0, 5, or 2, -3. We could make a table and graph it and see which of these points are on the line. But a lot of times we don't have great graph paper, so that could get a little rough. The best way to do this is to recognize that for each point, the first number is the x and the second number is the y. We can put the x's in and see if they equal the y. I will write it a nice legal mathy way. To check 1, 3, put 3 in for y here. Equals -2 times my x of 1 plus 1. Something worth noting is that above the equal sign, we should put a question mark because we don't know if they really equal each other. Let's figure out this side and see if it equals 3. -2 times 1 equals -2. Then plus 1 equals -1, which does not equal the y of this one of 3. So this point is not on my line. Good work. Let's see if 0, 5 is on it. My y is 5, so 5 equals question mark. -2 times 0 plus 1. Figuring out the x side, -2 times 0 equals 0, plus 1 is 1, which doesn't equal the y of this one of 5, so he is also a no-go. But I have a good feeling about the next one. Even if we know it will work, let's go through the steps. Put the x's and y's in. -3 equals question mark. -2 times 2 is -4. Plus 1 equals -3. So they equal each other, and this point is definitely on this line. This was an amazing introduction to attributes of lines. I'm sure you never thought there was so much to know about them. Let's quickly summarize what we know about lines so far. First, any equation with an x and a y where they are not raised to visible powers will create a straight line. Also, we can create a table of values that fit the x and y in an equation. The third thing we know is every point on that drawn line is an answer to the equation, even fractions and decimals. Fourth, the line crosses the y-axis, called the y-intercept, at the last number when it is written like this: y equals 5/1x plus 7. The fifth thing, to go from one point to another, I go up the number on the top, across the number on the bottom, and it is the same as the number in front of the x. This is called the slope. I am impressed that you stuck with me on seeing that for the first time. The solution in math is not a number, but a straight line. We learned some cool things about these guys that will help us later. If you're ready to practice making some tables, graphing some lines, and seeing if points fit on your graph, please go to my website, MathforAll.net, and print out a worksheet that is aligned to this lesson. Have fun and come back to learn so much more about lines and more about math.